Okay, I'm going to give a brief review here for today. It's Sunday. We're used to like breaking down kind of an angle. We're used to understanding degrees, not, in these, where a circle is broken up into 360 slivers, and we were kind of familiar with that. And now I've kind of introduced radians. Okay. A radian, we learned, is when we express an angle here, theta, in terms of basically its arc length in reference to the size of the radius. So 1 radian is when the arc length of an angle, this arc length equals the radius, okay? That's approximately about 57 degrees, 60-ish, okay? All right? Okay, we learned from our little wiki sticks that if we start here at standard position and we go counterclockwise, which is plus, that 3.14 radians is pi, but that's what it took. About 3.14 radiuses mapped out here. 1 radius, 2, 3, and a little bit more, 3.14 radiuses is the arc length of 180 degrees, and that's also what we've labeled pi. Pi represents that number, 3.14, and it goes on to infinity. We use pi because it exactly means 180 degrees, okay? Right. Remember, pi, 1 whole unit of pi is 180 degrees, and it's half a moon. It's half of a full circle, okay? All right. We started dealing with rotations, okay? A full rotation is 360 degrees. So I start here at 0. Notice how I'm on the x-axis, my initial position. And all the way around is 360 degrees. It's also pi, 2 pi. It's 2 pi all the way around, okay? So don't get confused when we compare, to show me where 7/8 pi is, or, and then we talk about rotations. Remember though, here's your XY axis. A quarter rotation is 90 degrees. That's also half a 180 or half a pi. Okay, so here's pi halves. Okay, 90 degrees is pi halves, all right? We had an example of, everyone seemed to kind of struggle with this. Let's talk about, write out the degree, or show me the angle and write it in radians. And this would be an example of something we did. 2/3 of a rotation clockwise, and let's say it in radians. Well, clockwise is going to be in the negative direction, okay? So, I'm going to start here. Let's get a good idea. First of all, I expect you people, students, everybody, to do this if it helps out. 2/3 of, remember what of means, 2/3 of means multiply, okay? 2/3 times 360 is 240 degrees, but that's a negative. We're going this way, which is negative, so negative 240, all right? So here's 90, 180, and plus 60 more. This is going to be 60 degrees, and I'm going to get to this later, but this angle is called a reference angle. It's the difference between the terminal side and the nearest x-axis. Okay, that's where we can build a triangle off of, and I can do, I know this is 60, this is 90, we can do adjacent, we can do our SOHCAHTOA here. All right, now let's do, so we know we have a good relative idea of where negative 240 is, or 2/3 of a rotation. Now let's talk of it in terms of pi. Full rotation in radians, it's 6.28 radius arc lengths on this circle. If I measured arc lengths based on the radius of the circle, there'd be 6 and basically 0.28 to go all the way around, or 2 pi. Okay? Just think, remember, pi represents 3.14-ish, okay? So there's going to be about, this is a little more than 6 radiuses that lay out arc length-wise to express this angle. We're expressing angles in terms of arc length based on the radius. So anyway, 2 pi is all the way around. 2/3 of a complete rotation in radians is 2/3 times 2 pi. 2 times 2 times pi is 4 pi. always leave this because we know what pi is. We know pi is this right here, the shaded area, okay? And 2/3, I'm sorry, so anyway, so we have, we can start, if we have fractions, break that up into how many slices we need. Anyway, getting back to this. 2/3 times 2 pi is 4/3 pi, and it's in the negative direction, okay? So it's really negative 4/3 pi. Conceptually in our head, remember, what's 1/3 of pi? That's 1/3 of 180, which is 60 degrees, okay? Again, I put this in here. Remember, we always just think we're going negative on this clockwise thing. Well, 60 degrees equals pi thirds, okay? So we said 1/3 of a pi. 1/3 of a pi is 1/3 of 180. So pi thirds, 1/3 of a pi is 60 degrees. So 4/3 pi, remember that's in the negative direction, is what? How many? We have 4 of these 60s. So that's 4 times 60 is 240. So it should make sense to you. Okay, so basically, I'm dividing pi into thirds, and I'm dividing this pi into thirds because we have more than 1. 4/3 is greater than 1. So here's 1, 2, 3 pi thirds, which is negative pi. We're going in the negative direction. And I've got my 4th third of a pi. Okay, so there's 240 or negative 4 pi thirds. Okay, that's coterminal with 2 pi thirds. 1, 2. There's 2/3 of a pi. That's coterminal. But anyway, all right. Okay. Now let's just kind of talk about finding what quadrant something's in. Okay. Here's 16/7. This 7, okay, is what pi is broken into. Just pi. Not a whole circle, but we're going to break pi into slices of 7. Okay, what quadrant is in? Remember, pi or 180 is divided into 7 slices, if whatever this denominator is telling pi is sliced into. Okay, so 7 slices is 7/7, and that's 1 pi. Okay, or 180 degrees again, all right? In your head, you can kind of think about, hey, what's 16/7? That, to me, that's greater than 2. So we're more than a full rotation. 2 pi, okay, is all the way around. Let's make a mixed fraction of it. 7 goes into 16 2 times with 2 left over. So basically we have a good concept. I'm going 2 pi all the way around, and I've got 2 more slices. This would be right here, quadrant 2. Okay? One way I could go about it, here I've broken up each pi into slices of 7. Here's 7, 7. Here's another, I need to go 2 and 2 7s, so I go, here's 1, 2, 3, here's 1 pi. 1, 2, 3, 4, 5, 6, 7, another pi, there's your 2 pi, and 1, 2 more. Quadrant 1, okay? Or you could just sit there and count 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, same thing, okay? I don't really need this, all right? If you want to convert it to degrees to get an idea exactly what you're dealing with, I want to go from radians to degrees, so notice degrees up top, 16 times 180. The pi's cancel out, right? Okay, so it's 16 times 180 over 7 gives me 280 degrees. Okay, I'm sorry, this is my numerator, and then I need to divide this by 7, I'm sorry. Okay, so up top, 16 times 180 is this, divided by 7. Like I said, the pi's cancel out, and I get 411 degrees, 0.429 roughly, all right? Okay, so that's where this is my drawing my angle, 411 degrees. This angle here, just so you know what this angle is, would be 411 minus 360. So this is about 51 degrees past the x-axis, okay? All right? So that is another way of determining what quadrant we're in. All right. Finally, I got about a minute or so. I don't want to go too long. It's 9:40. Let's talk about reference angles. Reference angles are, here's an angle in standard position, okay? The reference angle is going to be with the little hat on it. This will be this angle that's formed from the terminal side to the nearest x-axis. Okay? Let me get a little marker here. Okay, if you can see pink. Okay? So this angle here is my reference angle, and we'll be able to build a triangle. What we'll do is from this point, we'll go straight down perpendicular, and now I've got a triangle where I've got a hypotenuse, x, and y, and we can do SOHCAHTOA, okay? Remember, determining this reference angle would be 180 minus this angle. The difference between this angle and 180 degrees tells me this angle, okay? Obviously, this is quadrant 2. If you're in quadrant 1, your reference angle is theta. That is, and we could sit there, make a triangle here, come perpendicular down, okay? And here's your x, y, and here's your hypotenuse. And we can determine this angle, okay? Here, if I got an angle that's in quadrant 3, wherever this point is, I'll make, this is my reference angle. Reference angle's the difference between the terminal side and the nearest x-axis, okay? So this right here, theta hat, is this angle right there between the x-axis and the terminal side, the nearest one, okay? All right. Quadrant 3, this angle is 180 plus this reference angle, okay? Or if you need to determine what that reference angle is, it'd be the angle theta minus 180 will tell me what that angle is, okay? All right, and finally, so this is a reference angle in quadrant 4. We can build a triangle here and determine this reference angle right here, the difference between the terminal side and the nearest x-axis. It helps us build a triangle and find cosine. With being able to build these triangles from these reference angles, we can use SOHCAHTOA. We can use SOHCAHTOA and find out cosine, sine, etc. Okay, cosine, sine, tangent, anything. And if we do inverse, like if we build a triangle, we can do inverse tangent, okay, or inverse any function and get what the actual angle is, okay? We can do all kinds of things with that, with reference angles, all right? 12 minutes. All right. Tomorrow, we'll do maybe a couple problems where you're given a point. This angle, let's say -3,6. Remember, that's x, y. This would be a -3. This would be a +6. Okay? We do Pythagorean theorem. Notice how any negative squared is going to be positive. So I do Pythagorean theorem, 3 squared, 6 squared. Remember, negative squareds are positive. 9 plus 36. This is your a squared plus b squared. I'm solving for the hypotenuse. Okay? So this coordinate, like I said, we've plotted this coordinate. We draw a line to it. This is your hypotenuse. We build this triangle. Okay? And we can solve for all 3 sides, so we can do any of the trig functions. Okay? So all I'm doing here is Pythagorean theorem. -3 squared plus 6 squared is 9 squared plus 36 is square root of 45. I factor it 9 times 5, and that ends up being 3 root 5. This comes out as 3. Square root of 9 is 3. Here's my triangle. I've got all the sides. I can do inverse trig function. Here's, let's say, tangent is opposite over adjacent, 6 over 3. It's about 63 degrees. So that, my friends, is my reference angle. If that's 63 degrees, I'm in quadrant 2. It would be 180 minus that is about 117 degrees for this angle. Okay? 14 minutes, gotta go. Longest video yet. All right? Good night. See you tomorrow.